Hi, welcome back to the channel. In today's lesson, I want us to use this question to understand how to deal with trigonometric identities. But before we get into this question, I want us to remind ourselves of the basic trigonometry identities. Now let's see. We know that sec theta is the same thing as 1 over cos theta. Also, we should remember that cosec theta is the same thing as 1 all over sine theta. While your tan theta, our popular tan theta, is always given as sine theta over cos theta. And also, we also should remember that your cot theta is given as 1 over tan theta. And very popular, you always see this. You always see that sine squared theta plus cos squared theta is equals to 1. And also, let's remember our trigonometry. And also, let's remember our Pythagoras theorem. Pythagoras theorem simply tells me that if I have this triangle, label A, B, and C, such that this side will be my small c, this will be my small b, and this will be my small a. The length of b, which is the longest side and the hypotenuse of this triangle, Pythagoras theorem tells me that b squared will be equals to a squared plus c squared. With this said, I think we can now see the question. Let's get into the question. We're given that the root of 1 plus sine theta, we can easily re-express this to be root of 1 plus sine theta over root of 1 minus sine theta plus the root of 1 minus sine theta all over the root of 1 plus sine theta. Now let's take an LCM of this side. So if I'm taking an LCM, I should have 1 minus sine theta into the root of 1 plus sine theta. Now 1 minus sine theta here in this LCM, I'll be left with 1 plus sine theta. The root of 1 plus sine theta times the root of 1 plus sine theta, that's 1 plus sine theta. This is, let's change that root to raised to power half, which is the same thing, all squared, plus the root of 1 plus sine theta here, I will left with the root of 1 minus sine theta times the root of 1 minus sine theta. That's 1 minus sine theta all raised to power half, all squared. So 2 here is 1, 2 here is 1, 2 here is 1, 2 here is 1. Now this should be the same thing as 1 plus sine theta. I'll be left with 1 plus sine theta plus 1 minus sine what? Theta all over. Now the root of this becomes, I can express my LCM this way to now become the root of 1 minus sine theta into 1 plus sine theta. Now let's take another slide, so that 1 plus sine theta, 1 plus sine theta minus sine theta gives way. So for my numerator, I'll be left with 2. I'll be left with 2 over, now we have the root of 1 minus sine theta into 1 plus sine theta. Now when we are expanding, if we have x plus y into x minus y, you know that this obviously will lead to x times x becomes x squared, x times y becomes minus xy, y times x becomes plus xy, y times y becomes minus y squared. So at the end of the day, this becomes x squared minus y squared. The same thing is happening here. Here we are having, this expression is something as 2 over the root of, you have 1 minus sine theta into 1 plus sine theta, where 1 here is my x and sine theta is my y. So if I expand this, it becomes 1 minus sine squared theta. Now from our trigonometric identities, we know that sine theta plus sine squared theta plus cos squared theta is equals to 1. So that cos squared theta will be the same thing as 1 minus sine squared theta. So in place of 1 minus sine squared theta here, I can easily express this expression. Sorry, let me just cut this out. I can easily say this is the same thing as the root of cos squared theta. Now, so that is equals to 2 over cos squared theta. The root of cos squared theta is cos theta. So if this is 2 cos theta, 2 over cos theta. Now remember that 1 over cos theta is the same thing as sec theta. So that finally, the whole of this expression could be written as 2 sec theta. With this, I hope you now understand how to go about this, and I would like to see you in our next class. Thank you for staying with us, and do see you in our next class.